On November 19th, NASA announced its latest discovery. ThreeI Atlast may be one of the factors behind the current phase of intense solar activity. ThreeI Atlast quietly passes through the solar system just as our star repeatedly produces X-ray outbursts, X-class flares, powerful CMEs, and falls into rare planetary geometric configurations. Telescopes are forced to use long exposures stacking series of frames to pull the coma, the faint tail, and the thin jets of Atlast out of the background noise. NASA has begun to directly call Atlast a comet, while the observing community remains cautious because of its unusual interstellar origin. At the same time, solar storms distort the radiation belts around the Earth, and a quiet earthquake swarm appears off the coast of Japan, all of it as if merging into the same energy rhythm that Atlast is drifting through, instead of being seen only as a threat. Atlast is like a gentle reminder that the universe still holds countless mysteries yet to be solved, and tonight the Earth still has the right to set all hypotheses aside for a while, and sink peacefully into sleep. Before everything is brought to light, let us slowly follow the trail and ask ourselves, is ThreeI Atlast indirectly contributing to the changes of the Earth to the point of forcing Avi Loeb to send an urgent message to all humankind? Outside your window, the night feels still, but nothing in the sky is truly resting. Far above the quiet room, planets slide along their invisible tracks, and ThreeI Atlast glides between them. The solar system turns like a great slow clock, each world keeping time with gravity instead of ticking metal. Within that clockwork, Atlast is the unexpected hand that appears from outside the dial, moving to a rhythm no one here designed. The Earth spins gently under your body, carrying you eastward into the dark while Atlast drifts through the sun's faint outer wind. Cities dim their lights, but Atlast never sees night, only the constant grey of interplanetary space. Mercury, Venus, Earth and Mars orbit in a thin plane around the Sun, while Atlast crosses that plane on a steep foreign path. The known comets loop around and return, but Atlast falls through once, as if passing through a room it never planned to visit. Long before astronomers gave Atlast a name, the object had already wandered for millions or billions of years between distant stars. Now Atlast is part of our sky, for a brief moment, a visitor threading quietly through the geometry of the inner planets. The sun's light wraps around Atlast, lifting dust from the surface and drawing a faint veil behind the small cold body. From the ground, that veil barely shows, yet Atlast continues its patient motion, whether anyone is watching or not. Somewhere above the horizon, telescopes track Atlast as a tiny shifting point, hardly different from the background stars. To that point, our whole solar system is just another bright island along a much longer voyage that Atlast has not finished. You lie still while Atlast moves endlessly, your breath rising and falling more slowly than the orbits, but with the same quiet regularity. In this moment, your heartbeat, the spin of the Earth, and the long path of Atlast are all part of the same unfolding pattern. As you sink deeper into the calm of the night, the story of Atlast will follow the wind of the sun a little closer. From the surface of the sun, a bright disturbance swells and tears free like a thick wave of light beginning to rise. That wave is a coronal mass ejection, a cloud of charged particles and tangled magnetic field pushing out into space, and Atlast is somewhere ahead along its path. Behind your eyelids, the night is dark, but in the inner solar system, the CME spreads like a slow, luminous tide. The sun exhales, and the plasma front begins to race outward at hundreds of kilometers per second toward the region where ThreeI Atlast is drifting. On quiet screens in distant control rooms, models turn that invisible wave into coloured shells expanding away from the sun. In those simulations, one of the shells brushes directly across the line of Atlast's orbit, as if the wave has drawn a soft target around ThreeI Atlast. The numbers behind those pictures are simple at first glance. They take the speed of the CME, the position of the sun, the known trajectory of Atlast, and they estimate a day almost like a scheduled meeting between the storm front and ThreeI Atlast. Every modeler knows the limits of these forecasts, and the story of Atlast respects that uncertainty. Magnetic fields twist solar wind density shifts, and the real wave can arrive earlier, later, or slightly off track from what the diagram shows around ThreeI Atlast. Still, the geometry is suggestive. The same active region that has thrown powerful flares toward Earth now appears to be sending one broad exhale into the flank of the space where Atlast has recently passed perihelion. In your mind's eye, you can imagine the CME not as a threat, but as a moving, glowing curtain spreading through the dark. Behind that curtain, ThreeI Atlast hangs like a grain of stone inside a vast, faint lantern, waiting to feel the change in the surrounding field. As the front approaches, the solar wind around Atlast may compress, the magnetic environment may rearrange, and the coma of ThreeI Atlast may flutter or stretch. Nothing in this meeting is guaranteed, yet the possibility turns the journey of Atlast into a quiet experiment carved into the plasma around the Sun. You rest deeper into the mattress as the wave keeps moving far beyond your atmosphere and your weather. Somewhere ahead of that moving shell, ThreeI Atlast continues its slow fall through the system, carrying its ancient silence toward whatever the Sun's breath is about to write across its halo. The recent solar eruption spilled sideways from the Sun, away from the direct line to Earth, but still within reach of Atlast. While terrestrial space weather forecasters relax a little, ThreeI Atlast continues to drift through a region where the solar wind has grown restless. Before perihelion 3, Atlast looked almost star-like, a condensed point with only the faintest suggestion of a surrounding haze. Now the passage around the Sun has changed Atlast, and observers describe a broad diffused coma swelling around the interstellar visitor. Light from the Sun scatters through dust and gas released from Atlast, stretching a soft pale envelope outward in every direction. Behind that envelope, ThreeI Atlast carries a growing tail, a narrow river of material trailing downstream along the solar wind. Closer inspection of long, carefully stacked images reveals thin jets spraying from near the hidden nucleus of ThreeI Atlast. Each jet traces a line where sunlight-trapped gases and complex surface layers on Atlast meet and surrender material back to space. A few weeks ago, many telescopes struggled to show any clear structure, and ThreeI Atlast hid inside background noise and atmosphere. Now the same systems, using the same techniques, record a visitor that appears undeniably active with Atlast carving visible shapes in darkness. For comet scientists, this behaviour feels familiar, yet the interstellar origin of ThreeI Atlast gives every plume and every curve extra weight. Each new exposure suggests that Atlast is no cold relic, but a responsive body still reacting to heat, gravity and magnetic changes. As Earth moves onward in its orbit, the viewing angle shifts and ThreeI Atlast slides into a more favourable geometry for observation. From this new vantage, the coma of Atlast spreads sideways against the sky, allowing tails and jets to stand out more clearly. Somewhere between data and intuition, observers begin to speak of an awakening as though ThreeI Atlast has taken a long, slow breath. That sense of awakening gives Atlast a quiet presence in the story, a character now ready to meet the approaching solar disturbance. You rest deeper into the stillness while ThreeI Atlast continues to brighten every new night, placing Atlast further along its luminous arc. From here, the path of Atlast leads toward questions about plasma magnetic fields and the ways a solar storm can touch a visitor from another star. Far from Earth, a simple question hangs over the path of ThreeI Atlast. What happens when a strong coronal mass ejection sweeps across a small body, like Atlast, wrapped in a thin cloud of plasma and dust? Even now, no one knows the true size of the solid core hidden inside the glow of ThreeI Atlast. Early estimates suggested a nucleus just a few kilometres wide, but other readings hint that Atlast might be tens of kilometres across, heavy enough to hold a more complex history. Around that unseen core, sunlight warms buried ice and releases vapour, and the escaping gas drags dust into space. In long exposures, ThreeI Atlast appears as a bright centre, with a wide coma, while a tail is pulled away in the direction opposite the Sun, showing how the solar wind is already shaping Atlast. Past missions to other comets like the Rosetta spacecraft have watched what happens when a strong CME rushes through this delicate environment. In those cases, the magnetic field wrapped around a comet flipped the plasma around the nucleus reorganized and the tail broke away in a clean, sudden disconnection, before slowly rebuilding, as though the comet had exhaled and shed an old scarf of charged dust. Now the same possibility hangs above ThreeI Atlast. If a dense, fast-moving wave from the Sun reaches the region of Atlast, the magnetic sheath around ThreeI Atlast may be squeezed and twisted. Field lines could snap and reconnect, and the tail of Atlast could thin, kink, or even separate entirely before a new tail begins to grow. To those who watch the sky, this is less a disaster and more a rare experiment written in natural forces. 3. Atlast becomes a small laboratory, moving through the storm, silently testing how interstellar ice and rock behave inside a changing solar wind. As you drift towards sleep, the image remains simple and calm. Somewhere in the dark, Atlas travels on, and the breath of the sun draws closer, ready to trace a bright temporary scar across the halo of 3I Atlast before both return to quiet space. Around the world, small observatories and backyard telescopes turn quietly through the night, each one waiting for the faint light of 3I Atlast. Above mountain ridges and city roofs, domes slide open and mirrors cool in the darkness, while Atlast climbs slowly higher in the sky. Night by night, the geometry between Earth, the Sun, and 3 Atlast is changing. As the Earth moves along its orbit and Atlast glides farther from perihelion, the line of sight tilts, giving observers a more sideways view of the halo that surrounds Atlast. Earlier in the apparition, when 3I Atlast was closer to the Sun from our perspective, the tail of Atlast stretched almost directly away behind the nucleus. From Earth, that meant the tail of Atlast pointed mostly along our line of sight, hiding its true length and shape inside the glare of the coma. Now the scene is different, and the slow shift favours those who are patient with Atlast. As the angle grows more oblique, the tail of 3I Atlast begins to slide away from the centre of the coma on the sky, separating just enough for careful eyes to follow its curve. On computer monitors in control rooms, the tracking software shows a tiny crosshair sliding over star fields as the telescope follows Atlast. Each exposure is a short whisper of photons that left 3I Atlast many minutes ago, carrying information about dust gas and the solar wind wrapped around Atlast. Observers know that 3I Atlast is still faint and the sky must cooperate. Thin clouds, bright moon, or city lights can swallow the delicate haze around Atlast before it ever reaches the mirror. Those who travel to darker places do so for Atlast standing under cold air and quiet horizons to catch more of the subtle light. In those places, the glow of 3I Atlast can spread a little wider on the detector, hinting at the coma and tail that are still forming their full shape. From space-orbiting instruments with clear, steady views, sweep across the same region logging frames where Atlast is only a displaced speck among many stars. Later, those frames will be aligned and deepened, each one adding another layer to the picture of how 3I Atlast presents itself from this new angle. For now, the work remains simple and calm. Telescopes continue to listen to the light of Atlast tracking the visitor as 3. Atlast moves into a geometry that reveals more of its structure and prepares the way for deeper, more refined images in the nights ahead. On many screens, the raw images of 3I Atlast look strangely disappointing at first glance. Single exposures show almost nothing more than a slightly smeared star, and Atlast appears stubbornly ordinary. Observers know that the light from 3I Atlast is spread thinly across only a few pixels. Noise from the detector and the faint glow of the sky stand nearly as tall as the signal from Atlast. When a live stream shows only these single frames, viewers see a soft dot and little else. Some conclude that 3I Atlast has no real tail, no dramatic structure, just a tiny blur among stars. Astronomers work differently with Atlast. Instead of trusting one frame, they collect many exposures, each one a brief imperfect glimpse of 3I Atlast. Later, those frames are carefully aligned on the motion of Atlast, not on the background stars. The stars then stretch into lines or vanish into fuzz, while the light from 3I Atlast quietly adds up in one place. This process, called stacking, lets the true shape around 3I Atlast rise slowly above the noise. The coma grows clearer and a tail begins to emerge from the glow, a faint extension pointing away from the sun. In some stacks, narrow streamers appear jets reaching from near the hidden nucleus of 3I Atlast into space. Those jets are absent in any single raw frame, yet they are written consistently across many images of Atlast. The anomaly is not in the behaviour of 3I Atlast, but in the way different eyes look at the same light. One set of eyes sees only unprocessed clips and thinks nothing is happening, while another sees the stacked structure around Atlast and reads a more complex story. For those who work with long exposures, this is a familiar lesson that 3I Atlast quietly repeats. Reality can sit below the threshold of a quick glance, waiting for patient accumulation, before revealing its outline. As you listen, the idea feels gentle rather than technical. 3I Atlast invites a slower form of seeing one, in which many small moments are combined into a single clearer image. In the same way, your thoughts from the day can soften and blend as you rest. Like stacked frames around Atlast's scattered impressions merge into a calmer picture, preparing you to follow 3I Atlast into the deeper, quieter sections of the night story. In recent updates, mission schedules and press notes quietly mention a new target on NASA's list, and the name used is simple. The object is labelled as a comet, and that comet is ThreeI Atlast. On official graphics, Atlast appears alongside familiar solar system comets shown with a coma tail and a standard comet icon. The language sounds confident, as if the behaviour of Atlast has settled into a category that astronomers know well. Data from spacecraft and major observatories are grouped under headings that speak of cometary activity, and Atlast fits the description in many ways. ThreeI Atlast carries a diffuse coma, sheds dust and gas, and responds to sunlight and solar wind in patterns that resonate with comet physics. Yet for those who remember how ThreeI Atlast arrived, the label feels slightly too small. Atlast did not emerge from the Kuiper belt or Oort cloud we map around the Sun, and the orbit of Atlast is hyperbolic, pointing outward to another star. In quiet conversations and longer analyses, some researchers still prefer to call ThreeI Atlast an interstellar object. That phrase preserves the feeling that Atlast belongs first to deep space, and only briefly to our family of comets. The anomaly is not that NASA calls Atlast a comet, but that both descriptions can be true at once. ThreeI Atlast can behave like a comet in the inner solar system, while still carrying the history of an object born elsewhere. From a narrative distance, the dual naming gives Atlast a double identity. During this close passage, Atlast wears comet-like features, yet the long path of ThreeI Atlast through interstellar space never entirely disappears. For you listening in the dark, the tension is gentle rather than troubling. You can hold both images of Atlast at the same time, a comet in our sky, and a traveller whose story began far beyond it. In that sense, ThreeI Atlast mirrors your own experience. By day you belong to one world and one routine, and by night you drift into a wider, quieter space that only dreams can visit. As the chapter fades, the label matters less than the motion. ThreeI Atlast continues along its open orbit, and you continue to settle, letting the mind accept that not everything needs a single perfect name before you can rest. Sometimes the story of ThreeI Atlast is told not by what we see, but by what has not appeared yet. Screens refresh, mission timelines advance, and still the next clear image of Atlast does not arrive. In deep control rooms, raw frames must be checked, calibrated, and compared before anyone is sure what ThreeI Atlast is really doing. Data pipelines are long passing through instrument software and human review before Atlast is ready to be shown to the public. On the outside, that delay feels like a pause in the narrative of ThreeI Atlast. People who are watching for Atlast may look up schedules and expect an image on a certain day, only to find empty slots and quiet headlines. The numbers do not disappear, but they move slowly. Bits from spacecraft drift through antennas and servers, and ThreeI Atlast waits in those streams wrapped in compression and error checks. When nothing new appears on public pages, some wonder whether something about ThreeI Atlast is being held back. Others know that silence often means only that the work of understanding Atlast is still in progress behind closed doors. The anomaly is the gap between expectation and reality. Our minds move quickly, but the journey of ThreeI Atlast and the treatment of its data move at a steadier pace. In that gap, imagination begins to trace its own lines around ThreeI Atlast. We picture bright, dramatic changes or secrets hidden in the missing frames, filling the quiet with stories Atlast has not actually told us. From a calmer distance, the silence itself becomes part of the experiment. If we listen carefully, we see that ThreeI Atlast is also a lesson in patience, reminding us that not every moment of discovery arrives on demand. You can let this idea soften the edges of your thoughts. Just as stacked images reveal the tale of ThreeI Atlast over time, slow, careful analysis will eventually reveal more of what the instruments have seen. Until then, ThreeI Atlast continues along its open path, whether we have the newest file or not. The visitor does not hurry, and you do not need to hurry either, as the story of Atlast unfolds at its own speed. In the next part of this journey, attention will turn back to the Sun and its flares, and to how that changing light may reach ThreeI Atlast. For now, the quiet between updates is simply another dark space in which Atlast glides, and in which your thoughts can gradually dim. In the days since ThreeI Atlast rounded the Sun, the star at the centre of its journey has been anything but quiet. 4 times in a short span, the Sun has erupted with X-class flares, each one a sudden bright knot of energy woven into the path that Atlast is moving through. One of these flares climbed to X 4.0, a powerful spike even by solar standards, rising sharply on the graphs that track the heartbeat of the Sun. While ThreeI Atlast drifts in steady motion instruments near Earth, record that the X 4.0 flare briefly flooded the dayside ionosphere, triggering a strong radio blackout over the same broad region of the planet. On space weather plots, the 4 X-class flares line up, almost like beads, each one occurring within nearly the same 3-hour window in universal time. For people following ThreeI Atlast, this rhythm stands out. The sun seems to be ringing a bell again and again while Atlas continues its slow passage nearby. In the data, the pattern is clear and simple. Timestamps peak X-ray flux, and the mapped footprints of radio absorption all agree that the outbursts repeat in a narrow band of the day, even as ThreeI Atlast moves farther along its trajectory. The anomaly lives in that repetition. The sun has countless ways to flare, yet here are 4 strong events clustered in intensity and time playing out, while the geometry between Earth, the active region, and ThreeI Atlast keeps shifting. Some will see only coincidence, a brief burst of activity in a long solar cycle that ThreeI Atlast merely happens to share. Others, watching the same charts, wonder quietly whether the timing hints at some deeper sensitivity in the system that Atlast is travelling through. From the perspective of ThreeI Atlast, nothing about the flares is labelled unusual. The radiation and particles move outward at light speed and slower filling space, with waves and fronts that Atlas will meet only if the paths cross exactly. For you listening in the dark, the details blur into a simple image. The sun pulses 4 times with unusual strength, like a lighthouse turning its beam, and somewhere within that wider glow, ThreeI Atlast continues to glide unchanged in its calm, precise orbit. As the chapter turns, attention will shift from the timing of these flares to the positions of comets and planets around the sun. The path of Atlast will be traced against that larger pattern as we follow how ThreeI Atlast moves through a solar system that is briefly playing in a higher, brighter key. While the sun was sending out those 4 X-class flares, ThreeI Atlast was not the only icy traveller near the fire. Along the inner orbits, other comets were making their own close approaches, and Atlast was part of a small, quiet procession moving through the same bright arena. In late October, ThreeI Atlast swept through perihelion, passing closest to the sun and beginning to curve outward again. Just days later, A6 Lemon made its own tight turn around the star, and the path of Lemon crossed the same general quadrant of space that Atlast had just left behind. Farther along the calendar, another object, T1 Atlas, prepared to round the sun from a slightly different angle. As T1 Atlas closed in, observers traced its trajectory on the same diagrams that already showed the arc of ThreeI Atlast, noting how these lines of ice and dust seem to weave past one another in time. Seen from above the solar system, the picture is simple. The sun glows at the centre, the orbits of the inner planets form thin rings, and ThreeI Atlast cuts across those rings, while A6 Lemon and T1 Atlas thread behind and ahead of Atlast. On those overhead maps, the active sunspot region that launched the X-class flares rotates with the sun facing first the position where ThreeI Atlast was near perihelion, then the longitudes where A6 Lemon and T1 Atlas make their turns. The bright outbreaks repeat as if the same magnetic knot is watching each passage in sequence, while Atlast moves steadily outward along its open path. For solar physicists, the data show familiar motions. Active regions grow decay and flare as they rotate with or without ThreeI Atlast in the scene. Yet the timing of those flares around the perihelia of Atlast Lemon and T1 Atlas draws quiet attention. Some researchers treat the pattern as an interesting chain of coincidences, a run of active days in which ThreeI Atlast and the other comets happen to share the stage. Others allow themselves to wonder gently whether the presence of Atlast and its companions marks windows when the geometry of the system is especially responsive. From the point of view of ThreeI Atlast, there is only motion. The sun brightens and softens, the comets sweep by, and Atlas follows its own calculated curve, one thread in a larger tapestry that the solar system is briefly weaving. As you listen, the details resolve into a calm image of choreography. The comets arc around the sun in slow luminous lines, and ThreeI Atlast glides among them, part of a silent dance that will carry Atlast farther from the light in the chapters to come. When the same star flares again and again at nearly the same hour, the pattern invites a gentle question about Atlast. If the timing of these outbursts clusters, some begin to wonder whether the geometry of the system carries a kind of rhythm. ThreeI Atlast moves through a constantly changing arrangement of planets and fields, a shifting lattice of gravity and magnetism. At certain moments, lines from the sun through Atlast Earth or other bodies fall into sharper alignment as though the paths briefly lock into a simpler shape around Atlast. In this view, the solar system becomes more than orbits and dates. The distances and angles that include ThreeI Atlast could also be read as a slow turning pattern, a potential source of resonance that has not yet been fully mapped around Atlast. On paper, the data still look like numbers. Time's positions and flare strengths form clean columns, and no equation yet demands that ThreeI Atlast must be part of the cause. The anomaly lies in the way those numbers line up in time with the passage of Atlast and with key alignments. Again and again, the sun shouts in X-rays while ThreeI Atlast and other comets pass through nearby sectors of space, leaving room for quiet speculation. Some scientists stay firmly grounded and call it a coincidence, a natural clustering in a noisy system that would happen with or without Atlast. Others allow themselves a softer thought that maybe certain configurations focusing through ThreeI Atlast and the planets make the star more ready to release stored energy. For now, nobody can prove that the shape of the system is singing to the sun through Atlast. All that can be said with certainty is that the flares, the alignments and the path of ThreeI Atlast are sharing the same small window in time. As you breathe slowly in the dark, you do not need a final answer. You can simply imagine the solar system as a great turning instrument with ThreeI Atlast moving across its strings, while the star at the centre occasionally plays a brighter note. When the X4.0 flare erupted, the first question close to home was simple. Would the wave from that blast sweep straight into Earth, or would it bend away toward the region where ThreeI Atlast is drifting? Forecast maps soon showed a compromise. The shock front raced outward in all directions, but the densest part of the coronal mass ejection fanned off toward the western flank of the inner solar system, closer to the longitudes linked to Atlast than to Earth. On the diagrams, Earth sits off to one side of the expanding shell just inside the edge of the coloured rings. Models suggest that our planet will feel only a glancing blow, a passing compression of the solar wind strong enough for a G1 or G2 geomagnetic storm, while ThreeI Atlast lies closer to the fuller body of the wave. Monitoring spacecraft like Stereo A stand more directly in the path. In projections, those probes see a sharp rise in plasma speed and density as the CME front sweeps past, tracing a more forceful encounter than Earth will know, and hinting at what might be happening near Atlast. For ThreeI Atlast, the same front may mean a short, intense change in the surrounding wind. Magnetic fields wrap and squeeze, the coma responds, and any tail extending behind Atlast could flicker, bend, or briefly thin as the wave rolls through. To space weather forecasters, there is nothing alarming in a modest G1-G2 event. Lights may dance in higher latitudes, instruments may register the passing disturbance, and then the system will slowly relax while ThreeI Atlast continues its path through the region, just brushed by the main pulse. The anomaly, if there is one, lies in the shared timing. A powerful flare, a directed CME, a mild storm for Earth, and a stronger front sweeping the sector where Atlast travels all unfold, while the story of ThreeI Atlast is already bound to other flares and alignments. As you rest, the scene is easy to hold. A wave passes, Earth feels only the edge, and somewhere along the wider arc 3, Atlast drifts through the brighter part of the flow, a small silent traveller letting the sun's breath push gently against its halo before the space around Atlast grows quiet again. For a moment, step back from the graphs and charts that follow the flares and the path of ThreeI Atlast. Imagine the solar system laid out as a soft map of energy instead, with colour and light, showing where the wind of the sun is strong and where it is calm, and let Atlast drift quietly across that map. On this imagined map, Earth is a small, glowing circle, wrapped in a gentle blue-green shell, a marker where storms become auroras instead of numbers. Farther out, ThreeI Atlast is a tiny ember on the western side of the sun's influence, moving along a curved line that glows a little brighter wherever the solar wind touches Atlast more strongly. Each flare becomes a ripple on this chart's circular bands expanding outward in slow motion. You can see the wave from the X4.0 event sweep across the space between the sun and the place where ThreeI Atlast travels, a soft ring that brightens briefly as it overlaps the path of Atlast. In this view, there is no urgency, only the steady passing of pulses. 3. Atlast does not rush to meet or avoid them. Atlast simply follows the path carved by gravity while the waves wash over and around that path. Your own body can be part of this quiet map. You lie still on the surface of a small world, and with each breath your chest rises and falls like a slow local tide, while ThreeI Atlast moves through a much larger ocean of particles and fields. The same way stacked images reveal more of the halo around ThreeI Atlast repeated breaths, smooth the edges of your thoughts. With each exhale, the details of flares and dates blur, and only the calm motion of Atlast remains clear. Nothing in this pause demands an answer. 3. Atlast glides through the patterned wind, Earth turns under your resting body, and the sun continues to send out gentle waves of energy, all of them part of a single unfolding picture you're allowed to watch for a while before sleep. In the first days of January, the solar system leans into a geometry that feels unusually precise. Lines drawn from the sun through the planets begin to stack in a way that makes astronomers call this configuration one of the most important in many years, and ThreeI Atlast is quietly woven into that pattern. On overhead diagrams, Jupiter, Earth, Mercury, Venus and Mars all fall close to a shared axis with the Sun, forming a long narrow chain. The same maps show ThreeI Atlast gliding through the outer part of this layout, not at the centre, but still moving within the extended shape carved by these alignments, as though Atlast were tracing the outline of a subtle design. Near the Sun, inner planets pass through moments of perfect alignment called Cassini brief intervals, when they sit almost exactly between the Earth and the star. In this season, more than one planet reaches that position, and the sky clocks record successive Cassinis, while ThreeI Atlast continues its slow outbound fall from perihelion, sharing the same broad window of time. From a data standpoint, the configuration is simply rare. The orbital mechanics show that bringing so many planets into a nearly collinear arrangement happens infrequently, and the presence of ThreeI Atlast inside this geometry adds an extra layer of interest because Atlast does not belong to the Sun's long-term family. The anomaly is not that planets align, but that several significant alignments cluster together, while an interstellar visitor is still near the inner system. 3. Atlast moves along a path set long before this epoch, yet in this chapter of its journey Atlast happens to pass through a stage where many gravitational and magnetic influences overlap. For some, this is only coincidence written in orbital periods and angles. For others, the shared timing suggests a kind of heartbeat in the system, a moment when the combined pull of planets and sun may shape how energy moves, with ThreeI Atlast acting as one more small node in the network. In the quiet of your room, there is no need to decide which view is correct. You can simply picture the solar system as a long luminous corridor, with planets spaced along its length, and ThreeI Atlast drifting through one section of that corridor while everything briefly lines up. As the alignment builds, Earth continues its steady orbit and ThreeI Atlast continues its slow, precise arc. The story of Atlast will soon turn from this large-scale geometry down toward the shifting crust and oceans of a single world, but for now the scene remains wide and calm, a rare arrangement that ThreeI Atlast is passing through without haste. Far from the calm room where you are resting, seismographs along the coast of Japan draw quiet lines that sometimes jump. Over recent days, those instruments have recorded a cluster of small and moderate earthquakes offshore, a swarm of gentle shudders along the edge of a major fault unfolding, while ThreeI Atlast continues its own silent motion far above. On global maps, the dots marking these quakes form a loose chain in the ocean, all near the boundary between plates where past great earthquakes have begun. To the people who study such patterns, the timing of this swarm overlaps with the days when the Sun released its sequence of X-class flares, the same flares that trace part of the background for ThreeI Atlast. The data show magnitudes, depths and times. Many of the shocks are relatively shallow, and they cluster in a region remembered for the powerful event of 2011, a memory that makes experts watch more closely, but does not guarantee a repeat, just as the past path of ThreeI Atlast does not dictate its future. The anomaly, for those who notice, lies again in the coincidence. Solar activity has climbed, geomagnetic conditions have stirred, and during the same window a swarm appears offshore, all while ThreeI Atlast moves through a phase of its journey tied to planetary alignments. Most seismologists remain careful and calm when they speak about it. They know that swarms can fade without leading to anything larger, and that the connection between solar disturbances, deep Earth processes, and the path of ThreeI Atlast is still a field of open questions rather than settled answers. In their reports, the language stays measured. They note elevated activity outline scenarios and remind everyone that Earth's crust is always in motion, whether the sun is quiet or flaring, whether ThreeI Atlast is in our sky or already gone. From your vantage point, this becomes a gentle reflection instead of a warning. Our planet flexes and adjusts along its faults, the atmosphere shivers under space weather, and ThreeI Atlast glides through the outer layers of this environment, a distant witness to the way Earth continually reshapes itself. As you breathe slowly, you can let the idea settle. that constant movement is normal, not strange. The plates shift, the oceans roll, the magnetic field bends, and 3. Atlas passes overhead, all parts of a world, and a visitor that keep moving whether anyone is awake to watch or drifting safely towards sleep. High above the weather and clouds, Earth carries a quiet structure made of trapped particles and field lines. That structure is the radiation belt's overlapping loops of charged particles circling the planet, and Atlast is moving through the broader space where those loops unfold. From the side, the belts look like two bright donuts, one closer in, one farther out, wrapped around the magnetic equator. Solar storms can squeeze and stretch those shapes, and during the recent strong activity model suggests that the belts have been reshaped in ways that matter to the path of ThreeI Atlast. After a powerful storm, extra populations of particles can become trapped. Sometimes a third or even a fourth temporary belt appears, a new ring of radiation layered between the others, while Atlast glides through the same heliospheric environment just beyond the immediate reach of those rings. Satellites moving through these regions see their instruments respond. They measure changes in particle flux, watch boundaries shift, and help describe the invisible architecture that surrounds Earth, while ThreeI Atlast continues on the far side of this magnetic cocoon. The anomaly is not that the belts change, but how long the changes can last. A single strong event can leave the radiation environment altered for weeks or months, creating a new normal around Earth, even as Atlast has already moved farther along its outbound track. Scientists speak carefully about what this means for deeper layers of the planet. They know there is a connection between the space environment, the upper atmosphere, and the solid Earth, but the exact pathways remain uncertain, and ThreeI Atlast passes through this system, while many of those questions are still open. In some models, waves launched in the belts propagate downward nudging currents high above the surface. Those currents can shift how energy and particles flow, adjusting conditions that aircraft, satellites, and even the auroras experience while Atlast drifts in the larger sunlit sea of plasma beyond. For you lying in the quiet, it can be simpler than the diagrams. You can imagine Earth wrapped in soft glowing bands of charged light, a layered blanket that shields and shapes the space around the planet, while ThreeI Atlast moves through the outer weather of the Sun. The details of every interaction do not need to be solved tonight. Earth keeps turning under its luminous each blankets, the belts slowly reorganize after the storm, and Atlast follows its patient path through the same changing environment. As this chapter eases toward the next, the focus will shift from mechanisms to meaning. The story will return to the question of what a visitor like ThreeI Atlast might represent to a world watching these subtle changes, and how Atlast can become a quiet reminder of our place inside this layered living field. There is a softer way to look at ThreeI Atlast, one that does not ask for proof or fear. In that view, Atlast is less a threat or a mystery to solve, and more a quiet reminder that the universe is still sending us questions. Some people imagine that ThreeI Atlast could be a kind of constructed object, a probe wrapped in dust and plasma. Others see Atlast only as a natural shard of rock and ice from another star, behaving like any comet would in the inner solar system. The data we have on ThreeI Atlast do not force us into either story. They show activity a coma, a tail-changing light curves and hints of non-gravitational forces, but they do not tell us what Atlast means. In the spaces between those measurements, our own thoughts lean in. We project hopes, fears, and curiosity onto ThreeI Atlast, turning Atlast into a mirror for the way we feel about being small in a large cosmos. From that angle, it matters less whether ThreeI Atlast is a relic, a machine, or a wandering fragment. What matters is that Atlast arrived at a time when we are able to notice, record, and wonder, joining its path with our brief ability to pay attention. The anomaly then is inside us, not inside ThreeI Atlast. We are the ones who pause our routines because Atlast has brushed the sun and crossed our field of view, and we ask what else might be out there. For a planet that often forgets its own fragility, 3. Atlast is a soft tap on the shoulder. Atlast reminds us that the sky is not empty, that other systems exist, and that long, patient journeys are possible through dark space. As you lie in the quiet, you do not need to decide which story about ThreeI Atlast is correct. You can let Atlast be only a gentle sign that the universe is still unfolding, and that you are allowed to rest inside it. While your breathing slows, imagine 3, Atlast slipping farther from the sun, its glow fading but its path continuing. Somewhere in that ongoing motion, Atlast carries the unanswered questions with it, leaving you free to let go of them for tonight and drift into sleep.